Hello and welcome guys. So in the last video we have done model prediction on test set data. So in this video we are going to make a web application using Streamlit. So let's open VS Code. So from here let's open your folder in which we have saved our model and have our test images. Inside this, let's go in this plant disease copy and open this folder from here. So this is my folder. If I go in my test plant IPynb file, then you will see this Jupyter notebook here. So this is what we have done in the last video. So here we are doing some prediction, and here we are getting that it is having disease name as potato healthy. So this is a healthy image of potato plant. So our model is predicting here that this plant is healthy and there is no disease in this plant. Okay, so in this directory we will create one more file here. So let's create one file as main.py, and inside this we will make our web application. Okay, so to build your web application, first open your terminal. Also from here, if you are using Windows, then also you will go here in your VS Code, then you can open terminal from there. Okay, so when you open your terminal, then you will be inside your directory here. As you see, this is my plant disease copy directory. So activate your environment. So I am activating my TensorFlow environment which I am using for my model. So I am activating my TensorFlow environment. In this environment I have done everything. In the last video also I am using this TensorFlow environment. So in this environment I have all the libraries which I have used for our model. So inside this you have to install your if you don't have Streamlit library installed in your environment, then you have to do like here pip install Streamlit. This command you have to run in your environment. If you don't have Streamlit, then you will be able to install Streamlit. Okay, so I have already installed my Streamlit. Now we are ready to build application using Streamlit. So to check whether we have Streamlit or not, let's import Streamlit as st. Save this and run from here. To run your application, you have to type here Streamlit run and your file, which is main.py. If you hit enter, then you will get this localhost 8501, which is default IP for to run your Streamlit application. So we are getting some UI of Streamlit. Okay, now let's come here and do some import. Like here I have to use TensorFlow also to load my model. So I am using TensorFlow STF, and I am also importing import numpy as np. So we have imported all the necessary library which is needed here, and let's write here. I am creating a function to do model prediction. Okay, so I am writing here TensorFlow model prediction. Why I am creating this function? Because I want to make such a mechanism in which I just have to pass my image and it will give me a prediction, so that when we are going to create our web application, then we will upload some image, and once we hit enter, then this function will get triggered and it will execute and give us result. Okay, that's why I am creating some function here. So let's create a function define model prediction, and inside this I will take input as test image. Okay, inside this function what we have to do, we have to first load our model. So to load our model, we will use the same thing which we have used in this test plant. If I go in this test plant disease, this I have explained in the last video. So to load model, we have used this thing. Model is equal to tf.keras.models.load model, and we are loading this train model.h5 file or this train model.keras file. We have saved this model at the time of training, so we can use any file which we want. So what we will do, we will copy this thing from here and I am pasting here. So we have successfully loaded our model. Okay, and second step what we have to do, we have this test image, so we have to perform some pre-processing on this test image, then we have to do prediction. So here if you go, then you will see that at the time of testing, what we have done here, we have pre-processed by using this tf.keras.preprocessing.image.load image function. Inside this we have passed the image path, and this target size we are passing because we have trained our model on this 128 cross 128. That's why we are passing these things. And then we are converting this image into array form, because for prediction we have to feed to our neural network in the form of array. That's why we are converting into array form. And as our neural network is trained on batch of images, so we have to convert our input array in the form of batch. Okay, these things I have explained in detail in my last video. So what I am doing, I am copying this 3 line here from here, and I am pasting here. Okay, so we have successfully loaded our model in line number 7. In line 8 we are loading our image. So here we will change this with this thing. So this is our test image. So we are pre-processing our test image with this size, and then we are converting our test image into array. So whatever is stored in this image is going here, and it's converting into array, and then we are converting this array into batch. Okay, so once we see the size of this, then it will become 1 comma 128 cross 128. Okay, we have seen these things in my last video. If you print this, then we are getting this thing. So this is our image, which is having this height, width, and this is color, and this is 1 represent the batch, one training example in the batch. Okay, that's why it is 1. So the same thing we are doing here also. Okay, so this thing is same. And then if we go again here, then what we have done, we have applied this prediction, and we have done this model, we have applied this function model.predict on this input array, and then we are done. So I'm copying this one also there. So we got our prediction here. Okay, if you go here, we are getting this type of array here of having 38 classes. So our goal is to extract the maximum value from it. So that's why we have done this np.argmax. So we will do the same thing. This one also we will use. So let's write here, and then let's return result index. Okay, so we have created a function which will take any image, and it will return the result index from the model, and it will say that the model is saying that this index is having the maximum probability. So we will pass this index to the class name, and we'll get our prediction. That's what we are doing here. We have defined this class name, and then we are passing this class name here, and we are getting our prediction. Okay, actually we are getting the name of the class. That's why we are interested in index, and then when we pass this index in this list, then it will give us the name of that class. So the same thing we are going to do here also. Okay, so we have successfully defined our function which will return the maximum index of that class. Okay, and now we will make some UI also, UI of Streamlit. That is the main thing in this video. Okay, so to make some sidebar, first we will make sidebar. So to make any sidebar, you have to write this st.sidebar, and to give some title in the sidebar, you have to give st.sidebar.title. And inside this I will give dashboard, and once I show you here, if I refresh it, then you will see some dashboard here. So here in sidebar, this is our sidebar. So here we are getting some dashboard. Okay, we got our dashboard, and then we will define app mode. App mode is equal to, we will write st.sidebar.select box. We will define one select box here, and inside this we will write select page. So we are going to define 3 page here. So first one will be our home page, and second one will be about our application, and third page will be in this form, disease recognition. So this st.sidebar.select box will take 2 parameter. First in the form of string, which is the text of that select box, and this 3 element is in the form of list, which is actually the element of that select box. Okay, once we go there and I refresh it, then you will see this select page is the text here. This is select page, it is the text, and inside this we have three element in the list. So if I go here, then you will get home, about, disease recognition. So these 3 pages I have created here. Okay, so this is completed. App mode we have defined, and now we will separately define our home page, about, and disease recognition page. Okay, so first I am going to define my home page. So to define on my home page, I will write one condition, that if app mode equal home. I am saying that when in this select box I am selecting home, then trigger this thing. Okay, so then trigger this entire thing, whatever I am going to write inside this if statement. Okay, that's what I am saying here. So I will give some header first, st.header. Inside this I will say that in caps, I will say that it is plant disease recognition system. If I go there and if I refresh it, then you will see that this is plant disease recognition system. And if I go in second part, then you will not get anything, because we have not defined that part yet. We have defined only home page. So we are getting this home page as this one. And now I am going to pass some image here. So I am defining image path is equal to, I already have that image. Okay, so let me take that image first. Okay, inside this I have this image. So I am taking this image from here and I am copying this image in our working directory here. Okay, now let's go in VS Code. So you will get this home page image here. Okay, home page dot jpeg. Okay, we have defined our image. I have already selected one image for this application, and let's display this image. So to display the image, right here st.image. Inside this you have to pass your image path. I'm passing this image path, and second thing I'm passing this use column width is equal to true. This is I'm passing. I'm saying that stretch it according to our column width. So let's go there. So if I refresh it from here, you will see this image here. This is the image I have taken from Google. So this is our app image. So we are getting here image also. Now what we will do, I will give some markdown by giving some intro of our application, what our application is. Okay, so to give markdown, let's write here st.markdown, and this markdown is same as the markdown in our Jupyter notebook. Okay, the syntax of this thing is same. Okay, so let's come here, and to give markdown I have already prepared something for you. So let's go to my repository. So this is my GitHub repository. So here I have uploaded this main.py code. So here I have created this markdown for you. So let's copy this markdown, then I will explain you what we have done here. So I'm pasting this markdown here. Okay, so here I am saying that welcome to this plant disease recognition system, and our mission is to help in identifying plant disease efficiently. Upload an image of plant, our system will analyze it to detect any sign of disease. Together let's protect our crops and ensure a healthier harvest. Some text you can give in your application to tell about your application. You can give some text like this, and this triple hash is same as the hash in our markdown in Jupyter notebook. If you give more hash, then your text will get smaller. That is if you give single hash, then that is h1 header of HTML, and if you give two hash, then it will be h2 header of HTML, same like HTML. Okay, if you give more hash, then your text will become more smaller. So that is what I am doing here. I am using 3 hash here, and I am saying that we have to upload image, and then our app will do some analysis on that image and it will give us result. Okay, this is what we are doing inside our application. So the same thing in the text form I've written here. Okay, so once I save this and let's run this thing. So this is our application. Let's refresh this from here. So you will get this thing, welcome to plant disease recognition system, and this thing we are doing here. this thing is bold here. If you go there, then you will see why it is bold, because here we have used 2 star here. If you use 2 star in markdown, then you will get things in bold. So that's why we are getting this thing in bold form. And this point and 1 2 whatever you will write like this, same will be displayed here also. Okay, about us, learn more about our project, our team, and our goal on the about page. So this is what we are defining here, that we have disease recognition page. Inside disease recognition page, we are doing our prediction, and to learn about us, you can go on about page. Okay, so this thing, the complete description of our this application is given in this home page. Okay, this part is completed. So we have successfully completed our home page, and now what we will do, we will define our about page. So here what we will do, here we will write if app mode, same app mode is equal to about. We have defined here home, about, and disease recognition. So I'm saying that if we are selecting this about, then execute this thing, then execute whatever is inside this, and here write here elif, because at a time we are interested in selecting one thing. So that's why we can select only one thing. So whether this condition will be true, or this condition will be true, or the third condition will be true. Okay, that's why here write elif, and inside this we'll give header st.header, and let's give here header. So I am saying about, and here also we have to give some markdown. So let's write st.markdown. Inside this, create 3 quote here. I am defining 4 hash here. Okay, and I am writing here about data set. Okay, and inside this I am passing about my data set. So to pass about my data set, I will go here in my Kaggle here. This is the data set which we are using in our application. So I will copy this part here about data set part, and I will paste here. Okay, so we have successfully pasted this, and then we will define here with 4 hash the content. In content part, I am writing that we have train, and train we have 70,295 images. We have this much of images. If you go inside this, then you will find out that we have 70,295 files. So we have this much of images. And second thing is a valid. So in valid we have 17572 images, and in test we have 33 images. If you go in our here, then you will see that 33 test images is created for prediction part. Okay, so we have 33 images, and we have 17,572 images. If you go here, you will get it. Okay, so we have this much of images. So this is the information about our data set. If I save this, let's go here and run this thing from here. So this is our home page which we have defined. Let's go to see our about. So this is our about data set and content. This is the content of our data set. You can give more information here, like about your team and about future scope of this project. These things you can give inside this. I am giving this much only. Okay, now we will create our prediction page. I'm commenting here with prediction page. So I am saying that elif app mode is equal to, and I will use this thing when app mode value is disease recognition, this thing. Okay, when app mode value is disease recognition, then execute this part. Okay, so in this part what we will do, we will create one header first. So we will write here disease recognition, this thing, and then we will create one test image file uploader thing. Okay, so to create a file uploader in Streamlit, use this thing st.file uploader. Inside this you have to pass choose an image. Okay, if I save this and see our result, let's refresh it from here and go in disease recognition. you will get this thing. Okay, this is my header, and this is the text of this file uploader. Choose an image, which we are getting here, and this is our file uploader. Okay, from here we can upload any file up to 200 MB, and that file will be stored in this variable test image. Okay, this function will return the value which we upload there. That thing will be stored in this test image. And now what we will do, we have to create one button. So I will write that if st dot button dot, I will say show image. I am creating one button as show image. I am saying that if this button is pressed, then this st dot button function will return true. Okay, so then this condition will become true. So I am saying that if this button is pressed, then execute this thing. So show image will return the image of test image. Okay, so I am writing here st dot image, and I am giving that test image which we have uploaded in this uploader. And the second thing, I am giving it as use column width is equal to true. Let's go there and see what we have done here on here. Okay, so I've refreshed it. Let's go here, disease recognition, and I'm going this. Okay, plant disease copy. Inside this I am going in test. Inside this I am selecting this common rust, and this thing is uploaded here. If I click here show image, then it will show me this image. Okay, so we are getting this once we are clicking this show image button, then this thing is triggered and this thing is being executed, st.image, and we are getting this test image here. Okay, now we will create one predict button also. So what I will do, I will create here predict button. So I'm writing that predict button, and here in predict button I will say that if st.button, I'm writing the text of button as predict. I'm saying that if this button is clicked, then execute this thing, st.write our prediction. So let's save this and see. Okay, go here. If I go inside this show image, I'm getting this image. If I'm clicking on predict, then it's giving me this text, our prediction. Okay, fine. So this is working. Okay, so our prediction, and then we will execute this function, this model prediction function. We have our test image here, so we will pass this test image in this function and we will execute this function. So we will store that function result in this result index part, result index, and we will write model prediction function, and I will write this test image. Okay, so whatever image I'm getting from this uploader, I'm feeding that to this model prediction function, and it will return me the result index, okay, of that class. So we got our result index here. Now we have to define our class name. Define class. So to define class, let's go here in test, and let's copy this thing from here. This is entire class. Okay, so this is class name which I am going to use here also. So I'm copying this thing from here, and here I will say that st.success. Inside this I will pass that model is predicting it's a, and I will give this placeholder. So I will use dot format, and I will write here, I will write this class name here in this dot format, and I will use a result index here. Okay, so this index I am feeding to this list, and it will retrieve the element of that class. Okay, so it will give the class name. Okay, it's the same thing we have done in the last video. So I am saying by writing this st.success, that model is predicting it's a this class. Okay, so let's run this from here. So I'm going inside this, and let's refresh it from first. and let's do some prediction. So let's use this common rust part, and let's write here show image. So this is what we are getting, and our prediction is model is predicting that it's a common rust. This is what model is giving. Okay, so our prediction is right. So we can change this thing by doing something more here, like here we can give some effect, like here we can write st dot balloons. Write this, I think st dot balloons. Okay, right, this is correct. Let's refresh it from here, and if I am writing like this and I'm using some apple cider rust part, and I'm saying that this is the image, and if I'm clicking this predict button, then it will give some effect here, and then it will say that it is this is our prediction. So once we click this button, then this function will triggered and that effect will be shown, and then we will get our result. Okay, or we can give here st.snow also. So if I refresh it from here, if I go here and if I write like this, and if I show image, this is the image of tomato, which is healthy. If I click this, then we'll get some effect here of snow, and also we'll get this models predicting that it's a tomato and which is healthy. If you want to give some other thing, like you want to give some progress bar or spinner type of thing, like once you execute that, then it will give some spinner thing that please wait, and then it will give prediction. That thing also you can do from here. So what you have to do, you have to write here with st.spinner. Inside this you have to pass some message like please wait ... and inside this you have to execute this entire thing. So what it will do, this st.spinner will wait, will perform spinning, and that spinner will be executed, and this message will be shown until this entire piece of code which is inside this with statement is completed. Okay, so up to then this spinner will go, and this please wait message will be shown. Okay, so let's run this and execute that one. So I'm going inside this disease recognition. If I go and select something like yellow curl virus, tomato yellow curl virus, and show image, this is what we are getting. If I click on this predict button, this spinner is coming, and then this is our prediction. So our model prediction is very fast, so there is no need of spinner here. If you want to learn about st.spinner, then you go here and search st.spinner. You will get the documentation of this thing. So from here you can learn that temporarily display message while execution of block of code. So whatever code present inside this with statement, until that code is completed, this temporary display message will be executed, and it will be shown like wait for it. And then like here, if you see this example, and this wait for it, and along with this one spinner is displayed, this thing will be showed until 5 seconds, this time dot sleep, and after that this st.success will be displayed. Okay, the same thing we can do, like here we have, I think we have, okay, we have written this success also inside this. So let's write success outside this with, let's execute again that thing. Okay, go inside this and go tomato healthy, show image, this thing. Okay, please wait is coming, then it's saying that model is predicting that it's a tomato healthy. Or you can use that snow or that thing, and that thing is already I've uploaded in my GitHub repository also. So there I've used this st.snow. So you can use this st.snow directly, and after that you can execute entire thing. So once that button is clicked, then snow will be executed, and rest of the part of code will be executed. Okay, so you can use that thing. So that is how you can create this beautiful web application using Streamlit. So you can build this thing. If I go inside this and let me summarize what we have done. So first we have imported our library Streamlit as st, and then we have defined this function, a model prediction, which is taking test image and giving us a result index of that class. And then we have defined this sidebar, which is having title as dashboard. So this is our dashboard, and inside this we have defined this three select box: home, about, disease recognition. And we have defined separate three pages. We are saying, I'm saying that once this app mode is home, then execute this part, so this thing will be displayed on the page of home. So we have defined this header on the home page, and we have also used this home page image here, this thing. And this thing, I'm saying that put that image according to our column width, whatever present here, like here, whatever it is present, put accordingly. Okay, and then we have defined this markdown here, and then this about page we have defined, and then this prediction page we have defined. Okay, so here we have defined this file uploader. Inside this we are passing the image, and this is being saved in this test image. And then once this show button is clicked, then that image will be displayed by using this st.image. And when this predict button is clicked, then this entire thing will be executed, and this model prediction function will be executed, and then it will return the index, and that index will be passed in our defined class name. And at last we will display a success message that model is predicting that it is this it is having this thing, okay, this type of disease, whatever present in this class name. Okay, so that is how you can make a web application using Streamlit. So this is very good framework to learn, so you can practice this framework. And if you go in the documentation of Streamlit, then you will get a lot of thing here. So you can follow this documentation from here, and from setup and installation, API reference, you will get everything. In API reference you will see all the things, and they have given examples of each and everything, so you can use this thing. And to learn about markdown, go here to learn the markdown, like this, that whatever I have explained there, like this 2 star represent the bold form. So this is what you are getting here. So you can learn everything by using this documentation. This is very well arranged documentation they have given, so you can follow this documentation to learn more about Streamlit. So by that is how you can build a beautiful web application using Streamlit. Okay, so this is the final video of this playlist, and this playlist is completed. So if you want more video on convolution neural network or image processing or image classification or anything, please tell me in the comment box. And if you want something other than this image classification or anything, like if you want things related to natural language processing, some projects related to recurrent neural network, because previously I have uploaded fruits and vegetable recognition system, and this is a plant disease recognition system. So I have uploaded 2 videos on this. So if you want more videos on this, then please write in the comment box. Or if you want things related to natural language processing or recurrent neural network, then also please post in the comment box, because I am planning to make some video on recurrent neural network, and also some projects on recurrent neural network, and how we can do text processing using TensorFlow, and we can make a natural language processing NLP pipelines, and how we can perform some text classification things. So I am planning to make videos on NLP, but please tell me in the comment box. If the aim of this project is to give you idea that how we can make project from scratch. I've seen a lot of comment like here our model is only able to recognize the images of these classes which lie in these classes. If some images exist beyond this classes, then what we will do? So for that we have to make a very powerful model. We need GPU support to train very powerful model, and also we need data set, so that our model is capable of identifying each and every classes of image, because we have a lot of plants. So we have to collect the data set and we have to train our model. So this is how you can build any model from scratch. So the aim of this project is to tell you that how you can build your own model from scratch. Okay, so thank you guys. Thanks a lot for watching this video.